your first time watching me, my name is Priscilla Cancer. I'm a chemistry lab technician. Now, it's been a long time I shot a video. Yes, I know it's been a long time. I've been away for some time, but I'm back with new exciting videos. Now, today I'm going to synthesize M Dinitrobenzene. And I'm not going to do it alone as usual. You know, I always do it with my colleagues, but unfortunately the colleagues that I started these videos with, they are no more with me, so you'll not be seeing them again. But I have a new colleague here who is going to assist me synthesize it, and he's called Emmanuel Azan, Ima for short. So I'm going to invite him to join me here so that he's going to explain the theory aspect of the synthesis. Then he is going to carry out the practical aspect. So Ima, come join me. Alright, he's walking majestically. Okay, so that is Ima for you. He's going to explain the theory aspect, so I'll leave him to do that.
Alright, thank you so much, my boss. Thank you so much. As she rightly said, today we want to talk about the synthesis of meta-dinitrobenzene. Let's look at the summary of everything before we move to the mechanism of it. Alright, now in our first step, we will be mixing nitric acid and sulfuric acid. Nitric acid and sulfuric acid. And the aim of this is to produce our electrophile, which is the nitro group. Sulfuric acid, nitric acid is to produce the nitro group so that it can attack the nitrobenzene to form the meta-dinitrobenzene. Alright, so having formed our electrophile here, the nitro group, the substrate we are going to use, that's the nitrobenzene, we add that to the nitro group that is being developed. And this is what we are going to have. We can either have the auto, that is the nitro group can either come to the second position, the third position, or the fourth position. Also called the auto dinitrobenzene, meta-dinitrobenzene, and para-dinitrobenzene. But because nitro group on the benzene ring is an electron withdrawing group, and we know that electron withdrawing group are meta-directors, so the major product that is going to be formed in our reaction today is meta-dinitrobenzene. Now let's quickly move on to the details of the mechanism. Alright, so I've divided the mechanism into two, that is A and B. A is when we are forming our nitrating agent, B is we nitrating the nitrobenzene. In forming the nitrating agent, we mix sulfuric acid, the structure is here, with nitric acid. And our aim as usual is to produce a nitro group. Now remember that sulfuric acid is an acid, nitric acid is an acid. We know that acids are proton donors, but in this case both of them are acid. So the stronger one becomes the protonating acid. Alright, so sulfuric acid being the stronger one donate its proton to nitric acid. In mechanism, we see that the lone pair here takes the proton of the sulfuric acid, and this is what is formed together with this. Now, step 2 of the mechanism is that we know that water here is a leaving group. So what happens? Water leaves whilst the electrons here are donated to it to form. And when that happens, this is the water that has left. See the color of the nitrogen here? From the sulfuric acid, and this is our nitrogen. Now, the mechanism B aspect is we now adding the nitrobenzene to the nitrating agent or the nitro group. So these are nitrobenzene here, these are nitro group here. The benzene takes the pi bond or the pi electrons, attacks the electrophile. Remember, benzene here, nitrobenzene here is the nucleophile, so it attacks the electrophile, and this is what we have. Now, step 2 of that is that water in our system, which can act as an acid and a base, in this case is acting as an acid. So water remove the proton. Remember, there are 2 protons here, but it removes this proton because it is more acidic. Why? Because of the presence of the electron withdrawing group here. So it deprotonates the proton here, the electrons here are donated to form the aromatic back. And this all that. So this is what we call the meta-dinitrobenzene.
Alright, thank you, my colleague Ima. So he has explained it. He's coming to perform the practical aspect of what he said. So Ima, over to you.
Alright, thank you, my awesome boss. Alright, so first of all, we measure 11 ml of nitric acid into a round bottom flask, as you can see.
Now you can see the fumes coming out. It's conch nitric acid. So that's the fumes coming out.
Then we now add our sulfuric acid. Remember, we are doing this because we want to form our electrophile, the nitro group, as you can see from the A aspect of the mechanism. And this is 18 ml of conch sulfuric acid, so that we can form our nitrogen group. Now you add it gradually. The reaction is an exothermic reaction, so we have to do that in a cold water bath to absorb the heat that is going to be generated. Slowly, then you swirl.
Okay.
Wow, you see, you can see. Theoretically, the nitric acid is deprotonating the sulfuric acid to form the nitro group.
Okay.
Wonderful, as you can see.
I can see the fumes.
Alright. Alright. Now, we are done producing our electrophile, that is the nitro group. We gently add 5 ml of the substrate, that is the nitrobenzene, acting as our nucleophile here.
Okay.
Slowly.
Just like we did for the acid.
Exactly.
Okay. Yes, and you have to be very patient.
Yes. So
It's very explosive as well. So you have to be extra patient. Wow. Chemistry is beautiful, don't you think so?
Wonderful. Alright. So
We are almost done.
you're almost done. Now when you add, as you add, you are swelling, so that at least the attacking can be done proper. Okay.
The color of the mixture is yellow because of the nitrobenzene. Wow.
You see. Alright, so from here we are going to heat our mixture. The heat is to fasten the reaction. So that is that. So we are now going to the heating plate to mount it. Alright, so we are now at our heating plate. We have our condenser, the reflux condenser. So we are mounting it there carefully. Alright. We have our inlet, our outlets, the reflux condenser in. Then this thing will heat it for about 7 to 10 minutes. And when the reaction is complete, you see a brownish gas inside our flask. And that is a signal that our reaction is complete.
Alright, so if you don't have hot plate, just like we are using, you can use heating mantle. Anything that can provide heat, you can use that, okay? So we have to wait patiently for about 7 to 8 minutes for the reaction to be complete. Then we come back and we continue from there, okay? Trying to see. No, at least some, yes.
Alright. So you can see the brownish nature of the gas inside the flask. This is a signal that our reaction is complete. Our reaction is complete. Alright, so our reaction is complete.
This is ice bath. Ice bath. Contains ice cubes.
You gently remove, as you can see, the brownish nature of it. Very hot, so you carefully As I'm pouring, my rod will be stirring continuously. Alright. Dinitrobenzene is a yellowish crystal, so as I'm pouring, she'll be stirring continuously. Wonderful, beautiful crystals under. You can see that. Alright, so that is that. You can see crystals are forming under, but one thing you have to know is that you allow your content,
That's the mixture, right?
the mixture to cool to room temperature before you pour it into the water. Alright, you can see the beautiful crystals
Yes.
under. Oh, what a beautiful crystal.
You are going to filter it to get the crystals. Alright, so I have here filter paper. One of my videos I showed you how to fold filter paper. So you fold it like that, okay, like a cone, then I have my funnel here, so I'm going to put it in my funnel. Then Ima will pour it. Okay. This one you have to be very patient, okay? Very, very patient to get our crystals. So this is M Dinitrobenzene. That's the synthesis. It's very simple, right? Yes, very, very simple. I know some of you are wondering, what is it? How are we going to synthesize it? But this is it. It's very simple. Very, very, very simple.
Oh.
Yeah. And my colleague has really done well. Kudos to him.
Oh. She's the mitochondria in the cell.
Oh my God. Did you hear that?
Alright, so this is a crystal of methylnitrobenzene, which is yellowish in color. But this is crude. You need to purify it using recrystallization in pure ethanol.
Okay, so thank you very much, Ima. So viewers, this is M dinitrobenzene. We have to dry this in the oven. Then we determine the melting point. But as Ima said, this is crude. It is not pure. So from here, we have to dissolve it in ethanol to get the pure crystals. Now, when you purify it, it will not be yellowish as you are seeing. It will be white. Now, we've done some already and we wanted to show you. We are not going to purify it because it's going to be a long video. So this is a purified version of the dinitrobenzene. When it is purified, it looks more whitish than the crude. This is it. So this is the dried one, purified one. Yes. So this one, Ima did that. So viewers, unfortunately, we've come to the end of another exciting episode. Very, very unfortunate. And I want to thank my video director, Mr. Lawrence Umwapo Ajiman, aka Officer, aka Ajingo, aka Sello. He's laughing, yes. He is my video director. And my two Efos, Efo Felix and Efo Solo, do you remember them? Unfortunately, Efo Felix is not here. Efo Felix, if you are watching, please, I've missed you. Come and let's shoot more videos. Efo Solo is at the back. He's busy working on his project, so I'm not going to disturb him. And thank you so much, Ima, for this exciting practical. We are very, very grateful. And to my students, my colleagues, my viewers who are always watching my videos, thank you so much. Keep subscribing, keep telling your friends about Cristano Kim. We'll see you again in another video. It's bye for now. Adios.